Good morning 5B. Today is 10th July. No, today is 9th July. Okay, this is Tuesday. This is the first day of HBR. Okay. We should have gone through the lesson on using electricity safely and wisely lesson before coming to this lesson. So this lesson is just going through your review paper 1, which we did in term 1, but we haven't got the time to go through. So we're going to split this review test going through part into 3 parts. Up today 1 part, tomorrow 1 part, and Friday the last part. So there's only 3 days to do the going through, so I have to compact everything. So don't mind if the video is going to be quite long. Maximum I'm going to set it at 30 minutes. Anything more than 30, I'll just carry on the next day. Okay, so I'll try to limit it to 30 minutes as promised. So today I just want to try to complete question 1 to question 11. Alright, so let's start. So review test question 1. Okay, these are all MCQs. So let's look at the question. Okay, let's understand the question first. So what happens is that I have a dented ping pong ball. So you realize that this part is dented, is like pushed in. It's placed in a beaker of hot water. The keyword here is hot. Okay, the keyword here is hot. Okay, it doesn't work for cold water, it only works for hot water. So I have a dented ping pong ball, I put into a beaker of hot water and it becomes round again. So from dented, put in hot water, becomes round. Why? Okay, that's basically ask you to explain why. So look at the statement and see why. Or basically before we look at the statements, let's understand why first. Why from dented, put in hot water, it can bounce back and become circle again? What has the hot water got to do with all these things? Okay, so you realize that what happens is that the hot water is the source of heat. So maybe you want to write down this is the source of heat. Source of heat. Okay, hot water is the source of heat. Let's put an arrow. Okay, so hot water is the source of heat, and when you put the ping pong ball inside hot water, on hot water, you realize there's actually air inside the hot water, air inside the ping pong ball. Okay, there's air. So when I put the ping pong ball on the hot water, what happens to the air inside the ball? The air actually, okay, let's arrow this out. The air actually expands. Okay, so when the air inside the ball is heated, it expands. Okay, because it is heated. Okay, I use short form because it is heated. Okay, so once you put the ping pong ball that's dented into hot water, the air inside will expand because it gains heat. And maybe it's better to write it gains heat from the hot water. Okay, then for that part, I'll just put an arrow down. It gains heat from this. Okay, so then the ping pong ball there's air inside. I put it on hot water. The air inside expands because it gains heat from the hot water, and when it gains heat, it pushes against the wall of the ping pong ball, and the ping pong ball becomes circle again. Alright, so this is how it works. So let's see which one agrees with what we say. Ping pong ball increase in mass. No, there's no, it's still the same ping pong ball. Hot air enters the ping pong ball. How does it enter? There's no hole. Hot water enters. No, where's the hole? No, there's no hole for the air or the water to enter. And the last one, the air in the ping pong ball increase in volume, correct, because it expands. Okay, so when air expands, it increases in volume. Okay, so this is basically representing the expansion of air where when it gains heat from the hot water. Okay, so expansion. Okay, all right. Okay, so that's why the answer is 4. All right. Okay, so now go on to the next question, question 2. Okay, so it is about light. I have a towel, I have a torchlight. I know the torchlight is a source of light, so we're just gonna write down there source of light. Okay, so the torch is a source of light, and the towel, we know that the towel is opaque, so or doesn't allow light to pass through. So for notes, I'll just write what I know, doesn't matter. Towel is opaque, so the light travels from the torchlight to the screen. I put opaque object in between. Definitely I will observe a shadow. So maybe I use a black color pen. Okay, I'm gonna like draw like a shadow here. Okay, and the shadow must be of the same shape. Okay, so this is your shadow, and then I bracket it out. This is my shadow. So I will definitely see a shadow. Alright. Okay, so which one of the action will make the shadow bigger? I want the shadow to be bigger. Okay, so if I move, okay, let's examine each of these statements. If I move the tile closer to the screen, closer to the torch. If I move the tile closer to the torch, this one will cause it to block more light. Okay, so if I move the tile closer to the torch, the tile will block more light, therefore your shadow will become bigger. Correct. So A is correct. So let's put a tick at A. So I know definitely 1 and 2 is out. So by moving the tile closer to the torch, it will block more light because it's closer to the torch. Okay. So if I move the tile closer to the screen, okay. So what if I move the tile closer to the screen? When I move the tile closer to the screen, means the tile is further away from the torch, which means this one will block less light. If you block less light, the shadow will be smaller. So this one is wrong. Okay, let's put properly. Wrong. So B is wrong. So B is wrong. So straight away you know answer can only be D. But let's go through the rest as well. So same thing. If I move the torch away from the tile, okay, this is for C. When you move the torch away from the tile, okay, so basically this one goes backwards. This is for C. So when you move the torch away from the tile will actually block less light. Okay, because the torchlight is further away, so the tile will block less light if the torch is further away from the tile, so they will block less light, the shadow will be bigger. So and the final one, which probably is correct also, but probably is correct, but let's just check it out. If I move the screen away from the tile, basically if you realize that this is how shadow works. Okay, there's two lines here. So if I move the screen away from the tile, what happens is the shadow is gonna get bigger and bigger and bigger. As you can see, it's bigger now. Okay, so if you move the screen away from the tile, basically you are going to make the shadow much bigger because the light travels in a slant, in an open way, okay, away from each other. Okay, so if I move the screen away from the tile, it will block more light. Not say block more light lah, the image will be bigger. The shadow will be bigger, sorry. Shadow will be bigger. Okay. Right, that's why you see in cinema the projector is always at the back, further away, and the screen is far in front. Okay. So there's only A and only A and D is correct. A and D is correct. So answer is 4. Alright. So now we go on to question 3. Okay, I have several people trapped in a lift. So the keyword here is that you're trapped in a lift. You're trapped in a lift. No fresh air. So the air is kind of closed. No air can come in, no air can go out. Okay, so no fresh air can go in, no fresh air can come out because they are trapped. How will the gases change after 30 minutes? Okay, we know that there are people. This is the important thing. And what do people do? People being humans will breathe in oxygen and breathe out carbon dioxide. Correct? So this is what people will do naturally because we are human beings. Okay, people will breathe in oxygen, people will breathe out carbon dioxide. So if there's no fresh air coming in or fresh air going out, okay, the people are still going to breathe in the lift for 30 minutes. So if you are going to breathe in oxygen for 30 minutes, the amount of oxygen will have to decrease. So 3 and 4 is correct. And you're going to breathe out carbon dioxide, so the carbon dioxide in the lift will increase. Therefore, the one with 2 ticks is number 2. So answer is 2. Okay, so think about the question. Don't just read and then answer straight away. Think about the question. Think about, does it make sense to you according to what you have learned. Okay, go on to question 4. Okay, so question 4 says this. It's again a light question. So I have 3 different objects. Each time instead of 1 object, she placed 2 objects in front of the torch, and then she recorded if the light can pass through. So this is not about shadow per se, this is about whether light can pass through. So this is a bit tricky. This is a good question. So let's see how to answer this. If I put N and P in between, no light was observed. So I know straight away N, okay, I mean I cannot say for sure, but I know definitely at least one of them must be opaque. That means does not allow light to pass through. So we just put a question mark for the things we don't know. This one might be okay, we just call it allow or don't allow light. Okay, just call it allow because we don't want to use opaque, translucent, or transparent. So this one may allow. Okay, so this one may allow, so I'll put it as A question mark. Allow means A. Don't allow question mark. Okay, this one is P may be the one allowing light to pass through. P may be the one that don't allow light to pass through. So question mark. Okay, so A means allow, DA don't allow. The fact that I know there was no light observed means something was blocking the light. Might be N, might be P, might be both, I don't know, but definitely one of them blocks light. Okay, so I'm gonna write it over here. At least one, can be 2, at least 1 blocks light or don't allow light to pass through. Okay, this is for this one. Okay, make sure you can see everything. Okay, make it smaller for you. Okay, something like that. Okay, so for the first one, we know that at least 1 blocks the light. Okay, maybe 2, we don't know. That's why both have A and DA. Okay, let's go to the next one. I put M and I put P. Okay, the strange thing about when I put M and I put P together and I shine the light through, when I put M and I put P, I can see some light. Means for sure, I can say that this allows light to pass through, this allow light to pass through, because the light can pass through both objects for me to see the light on the screen. Cannot be one is opaque. If one is opaque, I will see no light at all. Okay, so I know for sure M is allow light to pass through, P allow light to pass through. And in this case, now I can do something to my first one. Since I know P is definitely allowing light to pass through, I can erase this away, knowing that this is definitely allow light to pass through. Okay, sorry, I erased the wrong thing. Okay, and if this allows the light to pass through, and for the first experiment there was no light observed, means that N must be don't allow light to pass through. So this is a definite thing that I know. Okay, so let me just run through with you again. The fact that these 2 put in between, I can see some light, means these 2 allow light to pass through. And if P allow light to pass through, means that over here is the same material, so you also allow light to pass through. And the fact that I cannot see any light must be because N is don't allow light to pass through. So this one I'll write don't allow light to pass through, this one allow, and then of course if one don't allow means there will be no light, and this confirms what we say so far. So with that being said, let's see the answer. M must be something that allows light to pass through. So let's tick on those that's correct. Clear plastic, yes. Clear plastic, yes. Frosted glass, no. Wood, no. Okay. N must be something that don't allow light to pass through. Correct. Cardboard don't. Styrofoam board don't. Clear glass will. Styrofoam board don't. So it's correct. P will allow light to pass through. Allow light to pass through. No. No. And no. Okay. Did I make a mistake somewhere? Oh, okay. I think I made a mistake here. Okay, frosted glass. Okay, so frosted glass, to me it doesn't allow light to pass through, but we know that frosted glass is translucent. Frosted glass can allow some light to pass through. So the keyword here is some light. Not a lot of light, but some light can pass through. So let's try again. Okay, we know M must allow light to pass through. Wood cannot for sure. Clear plastic can. Frosted glass, some light can pass through. So let's put a tick here first. Then N, don't allow. Cardboard don't allow. Styrofoam board don't allow. Styrofoam board don't allow. So these 3. And then for A, for P, it allows, so it must be clear glass out of these 3. The one with all 3 ticks is 1. So answer is 1. Okay, so this is a good question, quite difficult. So pay attention to this. Okay, Next question, question 5. Okay, question 5 is about digestive system. So I just finished my lunch, which one shows the what happens to the digested food. So the keyword here is digested food. I finished my lunch, which one shows what happens to the digested food and it moves from small intestine to large intestine. That means the last part over here. So you're looking at this part, okay, small intestine to large intestine. So you're looking at this part, whether it's correct. You're looking at this part, and you're looking at this part, okay, whether it's correct or not. Okay, so from the mouth, this is a mouth of undigested food. Basically, no, it's undigested, undigested. Okay, a food that is cannot be digested or not digested. Okay, so it starts off a lot with the mouth because the mouth, when we eat, the food is not digested. For example, the cheeseburger that we eat, it's not digested at the start, so it goes down slightly, stays the same throughout here, goes down from the stomach, and then goes down some more in the small intestine, and then from the small intestine to the large intestine, uh, it goes up a little bit. Okay, so it starts from here first. Okay, uh, okay, so it goes. You realize undigested food is getting digested. That's why it's always going down. So you should see a downward trend. Okay, okay. So what happens is that the general trend of the graph should be downwards because the undigested food is being digested, or because the yeah because more and because the undigested food is being digested. Okay, from the mouth all the way to the small intestine. Okay, so it will start with a lot first, and then subsequently it becomes lesser, 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 lesser. So this is the trend. Okay, let's write it here. Okay, so you should observe a downward trend. Okay, from where to where? From the mouth to the small intestine. Remember the question asked you what happens from the small intestine to the large intestine. Okay, so the trend from the mouth to the small intestine is that the line will go downwards because the undigested food has been digested. So it goes down, 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 down. Suddenly undigested food go up. Can undigested food increase when you digest the food? No. Okay, so undigested food cannot increase. Okay, so no, you cannot have suddenly more the undigested food in your system. So one is wrong. This one, undigested food goes down, 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 and then after that it becomes zero. Okay, that means it's either complete digestion or there's something wrong here. So in the mouth it's being digested a bit, gullet stays the same, stomach goes down, small intestine digest some more. Over here shouldn't go down some more, it should be flat. Okay, so if you're looking for a flat one, the only one is 3. Okay, because from the mouth you eat the food, it's been digested, get transported to the stomach by the gullet, nothing happens, and then in the stomach it digests even more, in the small intestine it digests even further, and digestion is complete over here. Okay, so at this point digestion is completed. Okay, so when digestion is completed there will be no further digestion, and that's why the line should be straight. Okay, so the answer is 3. Again, you will not see an increase in the amount of undigested food, so the answer is 3. Okay, so this one really tests your understanding of where digestion ends. Okay, okay, question 6, digestive system. Okay, tell me what are all these parts. So same thing, P is my gullet, don't mix up with windpipe. Q is my stomach, R is my large intestine, and then S is my small intestine. So be careful when you see the diagram. Okay, so this is all the parts that you should know by now. PQRS represents different organs, correct? Which of the statement is false? I want wrong one. Which one is false? Okay, digested food is completed in R. Digested food is only completed in the small intestine. R is large intestine, so R is wrong. Okay, by right it's supposed to be S. So this is wrong. This is supposed to be S. So R is wrong. P transports food from the mouth to the stomach, correct? The mouth was on top, it transports it to the stomach, so this is correct. Digestive juices are released in Q, so Q, stomach got digestive juice, so correct. Digested food at S, small intestine, is absorbed into the bloodstream and carried to the other parts of the body, correct? Because we know that as small intestine, besides digesting, is also absorption of digested food. So correct. So only one that is false is 1. So question 6 is 1. Okay, let's go to question 7. Okay, this one is P5 work about your stomata. So I pluck a leaf from a plant and place it in a beaker of hot water. We did this before. We know that there are bubbles, and we know the bubbles is basically air. Okay, and why is there air? Because the air is escaping from the stomata. So write down what you know. Okay, so this is from the stomata. Okay, so you know you have done this before. Just recall. That's why we always do experiment in class. Okay, so you know that the air is escaping from the holes on the leaf, basically what we call them as tiny opening, stomata. Okay, stomata. So the bubbles form only on the lower surface. So you realize in this case, of course in the real case we see on the lower and upper surface, but in this question it is only formed on the lower surface. Which conclusion is correct? Okay, so it is only on the lower surface. So forget what you learned before. They say now it's only on the lower surface. So which one is correct? You want correct. Okay, so air escapes through the opening found on both surface. There's only lower surface got bubble. So you cannot say that based on this, you can tell me that both surface. No, only the lower surface. So 1 is wrong. Bubbles form in the water and land on the lower surface. Did it form in the water? No. Okay, the water didn't come from the water. The bubble came from the leaf. So the bubbles didn't come from the water, bubbles came from the leaf, so it's wrong. The leaf has opening on the lower side, correct. There are stomata on the lower side, but not on the upper side. That's why you don't have bubbles on the upper side, on the upper surface. So number 3 is correct. Air enters the upper surface. Do we know? We don't know. Okay, we cannot tell. And escapes through a lower surface. Maybe correct, but we don't know about the first part. So the only one that's correct totally is number 3. Okay, is that the leaf have stomata on the lower surface, but not on the upper surface for this question only. Okay, in usual, of course, in the real life case, it has stomata on both sides, on both surfaces, so that there are more on the lower surface to prevent the evaporation, to prevent a lot of evaporation of water, a loss of water. Okay, we have around 8 more minutes. Let's try to at least finish 9 and 8 and 9. Then maybe we leave 10 and 11 to tomorrow. The diagram below shows the direction of blood flow in some parts of the body. Okay, we always start with the heart. Heart pumps to the rest of the body. The rest of the body returns back to the heart. The heart pumps to the lungs for gaseous exchange. The lungs push the lungs. The blood from the lungs will then return back to the heart. It's a cycle. Okay, so blood was taken from ABCD, which shows the correct comparison of the blood samples. Okay, which one shows the correct comparison of the blood sample when looking at oxygen? So we're looking at oxygen. So let's talk about oxygen over here in the diagram before we look at the graph. We know that when the blood comes from comes from the lungs to the heart, this must be rich in oxygen. Okay, so of course when it comes from the lungs after gaseous exchange, it's rich in oxygen. So same thing, the heart pumps the rest of the body to supply the body with oxygen, so this is also rich in oxygen. Okay, so after that, after the blood rich oxygen goes to the body will absorb the oxygen, and once the oxygen is absorbed, D must be poor in oxygen. And then of course it goes back to the heart pumps back to the lungs for gaseous exchange, so this part for A will also be poor in oxygen. Alright, so you need to understand this flow before you go and look at the diagrams, the bar graph. So which one shows the correct comparison of oxygen? Okay, B and C is high, A and D is low. So A is high, which is wrong. A cannot be greater than B, B must be greater than A. So this one is wrong. A more than C. A is poor in oxygen, so this is wrong. B is greater than D. B is rich in oxygen, D is poor, so this is correct. And D is greater than C. D is poor while C is rich, so this is wrong. So the correct answer is 3. Okay. So as long as you know the flow, as long as you understand what you're doing and understand the diagrams, right, this is actually quite straightforward, right? So let's go to page 7. Let's at least finish 9. Let's see how it goes. Okay, I put a well-watered plant. I water the plant, and then I put in a glass case. Okay, as you can see, there are no holes. Okay, glass case means what I know, definitely light can pass through. Okay, so if it's a glass case means light can pass through. Okay, but you realize there's also no holes in the glass case, means that no air can come in, no air can leave, no air can enter or exit. Okay, so these are the two things I can tell from the glass case, from the diagram and from the material that's being used. So glass case, light can pass through, so the sunlight can go in, but because it's a case, no air can enter, no air can exit. And then I put a plastic bag around the pot to prevent water from escaping. Okay, so this is not so much about water, this is about um, gases in the glass case. So at the start of the experiment, I have this amount of gases. Okay, and they ask you after 3 hours how will it change. Let's go to the straightforward one. Let's look at nitrogen. Okay, let's look at nitrogen. Will the plants absorb nitrogen? No. Will the plants take in nitrogen? No. Will the plants remove oxygen? Sorry, let's go, let's restart. Will the plants take in nitrogen? No. Will the plants give out oxygen, nitrogen? No. So we will expect this to be no change, no change, and no change. So it cannot be 1. Okay, because the plant doesn't need nitrogen, the plant doesn't give out nitrogen too. So nitrogen will come unchanged. Again, this is the same kind of question like the one that we saw just now about people trapped in a lift. This is now a plant trapped in a lift. So same thing, the plant also absorbs oxygen. Okay, sorry. So same thing like humans, the plant also breathe in, breathe out. So what happens that the plant will also use oxygen. Okay, so we know that plants will also use oxygen, so we expect it to go down. However, this is a plant, this is not humans. Humans can only use oxygen, but this is a plant, there is sunlight, we know that it can make food, and in the process it will also produce oxygen, so it will also give out oxygen. So as it uses, it also gives out oxygen. Okay, so unlike human, like just now the leaf example where we say that humans only use oxygen and give out carbon dioxide, this is a plant, there is sun, so the plant is making food, and as the plant uses oxygen to breathe, as it makes food, it also gives out oxygen, so it's actually using and replenishing at the same time. So kind of in a sense it will be roughly the same, but we'll see how it goes first. Okay, so same thing over here, carbon dioxide, we know that it gives out carbon dioxide. Okay, we know it gives out carbon dioxide, we just leave it as gives out because it is breathing, it is taking oxygen, giving out carbon dioxide, but it is a plant, so there's sunlight, so it's making food, so it will also take in carbon dioxide to make food. So realize for carbon dioxide and oxygen, it is both taking in, using it, and giving it out. So you realize, hey teacher, but it just increase or decrease, but there's no keep the same. Okay, so you need to think about it. When the plant is in the daytime, okay, when there's sunlight, okay, it is making a lot of food. Okay, there's very strong sun. So what happens is that actually the amount of carbon dioxide taken in is greater. Okay, and therefore the amount of oxygen given out would be greater as well. Alright, so although it seems like I take in some, I give out some, it will be equal, but when it's making food, it will take in more carbon dioxide, it will give out more oxygen. So the amount of oxygen will increase and the amount of carbon dioxide will decrease. So the answer is 3. Okay, so when it's making food, it will actually take in more carbon dioxide than what it gives out. It will actually produce more oxygen than what it takes in. Okay, So this answer is carbon dioxide decrease, oxygen increase, nitrogen no change. So answer is 3. Okay, it's 30 minutes, so I will stop here. So I will just carry on question 10 and 11 for tomorrow. All right, so make sure you get the corrections done, including all the notes on your hard copy review paper. Okay, see you tomorrow.